How then do we solve a system of equations using Gaussian elimination? Well, the first thing you have to know is what your goal is. In this case, the goal is to get all ones and zeros on the left with some numbers on the right. I hope that recorded because there was a crazy looking thing on my screen. Alright, so whenever you have your goal, remember your ones go on the diagonal from upper left to lower right with zeros everywhere else. So it has to be in this form. 1, 0, 0, 1. It's always that. Okay, so you always know your goal. So we set up our augmented matrix. 1, 3, 8, 2, negative 1, 9. To set up your augmented matrix, your equations do have to be in this standard form. X plus 3y equals 8. Remember, ax plus by equals c. They have to be in that form when you set up your augmented matrix. Now there's a very specific order you go in to get your matrix to look like this. First you get the 1, then you get the 0. Then you get the 1, then you get the 0. That's the order you must go in. Doesn't work any other way. So the cool thing is we already have the first 1. Now we need this to be a 0. So you can refer back to that first page and look at your rules. But the rule is you add if you want, or multiply then add if you want to get a 0. So this is what I always say. What do you add to negative 2? Sorry, what do you add to 2 to get 0? A negative 2, right? You add a negative 2. Well, I need to multiply that by row 1 and then add it back to row 2 so that I get a new row 2. Think about it up here. If I wanted to get rid of this x, wouldn't I multiply this row, this equation, by a negative 2 and then add these together? That's the process. Negative 2 times this one plus this one gives me a 0 right here. Let's do that row operation. It says we're getting a new row 2. That means row 1 stays the same. Negative 2 times row 1 plus row 2. Negative 2 times this one plus this one. So negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times 3 is negative 6. Negative 6 minus 1 is negative 7. Negative 2 times 8 is negative 16. And negative 16 plus 9 is negative 7. So we literally do this row operation to get this matrix. So we have our 1 and our 0. Now we need our 1 here. To get a 1, you're only allowed to multiply or divide. This is row 2. So I take row 2, divide it by negative 7, because that will give me a new row 2. That means row 1 stays the same. Everything in row 2, I divide by negative 7. Finally, I need a 0 here. What do I add to 3 to make 0? A negative 3. Multiply it by the row with the 1 in it, which is row 2. Add it to row 1 to get a new row 1. So we're going to multiply this by negative 3 and add it to this one so that this becomes 0. That means that's supposed to be row 1. That means row 2 stays the same. Negative 3 times row 2 plus row 1. So negative 3 times 0 is 0, plus 1 is 1. Negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times 1 is negative 3, plus 8 is 5. Now you remember when we set up our matrix, the first column represented our x's, the second one represented our y's, and then of course we have our constants over here. Well, this represents our x's, this represents our y's. So isn't this 1x plus 0y equals 5? And isn't this one 0x plus 1y equals 1? Well, this just means x equals 5, and this means y equals 1. That makes your solution 5, 1. And of course you can check that to make sure it's true by substituting it back into the system of equations.